So today we're going to be talking about lesson 2 of this third unit, and these are some of the main goals that you should be able to do by the end of this lesson. So we want to be able to explain why chemical equations are used, identifying the parts of the chemical equations such as the reactants, products, what yields mean and how you describe that, and any catalysts that we might need to use. We want to be able to balance them and identify the law of conservation of mass, also explain how the law of conservation of mass is related to balancing equations. So in terms of describing chemical equations, basically chemical equations tell the reaction that's happening. You have the reactants, which are the stuff on the left, or the beginning side of the arrow, and then you have the products, which are the materials that are the result of the reaction. So it's really important to know that these chemical reactions, all of them deal with chemical changes in substances. So bonds are broken in the reactants and new bonds are formed as substances become products. So when we talk about the structure of chemical equations, we want to be able to work out a couple of these examples so that we can work through these and label these chemical equation parts in general. So when we look at this first example here, so we have lithium chloride reacts with sodium sulfate to form lithium sulfate and sodium chloride. So we're going to look at this example and try to write this balanced, or this equation first, then we'll talk about balancing them. So we have lithium chloride, so that's going to be our first reactant. So lithium chloride is Li. If you look at the periodic table, lithium is essentially in the first column, so it's just going to be a +1 charge. So we write out lithium chloride as LiCl. Now that's going to react with sodium sulfate to form lithium sulfate and sodium chloride. So we have lithium chloride so far. You need to know sodium sulfate. Sulfate is one of those polyatomics we went over. It has a -2 charge, so that's why there's this 2 here. Then that's going to react to form, or to yield, which is why we need an arrow there, lithium sulfate and sodium chloride. So we're going to write that out as lithium sulfate, with that 2 there again, and sodium chloride. Okay, so that's what that full example is going to look like there. So we have LiO and NaSO4. Okay, the second example here, we're going to have iron reacts with oxygen yielding iron 3 oxide. So we have iron by itself reacting with oxygen. Remember, oxygen is a diatomic, so it's going to be O2. That's going to yield iron 3 oxide. That means iron has a +3 charge. So the charges are going to crisscross and we're going to get Fe2O3. Now we're going to have the next example, silver nitrate reacts with hydrosulfuric acid to produce silver sulfide and nitric acid. So we have silver nitrate. That's going to react with hydrosulfuric acid, which is H2S. And that's going to produce silver sulfide and nitric acid. So we're going to get Ag2S for silver sulfide. And the rest of it's going to be HNO3 for nitric acid. Okay. Now, based off of the law of conservation of mass, we essentially are going to have this idea that matter is not created or destroyed. Simply, atoms are just rearranged so we don't lose anything in the process. So mass cannot be gained or lost during a chemical reaction, and for this reason we have to make sure we balance the different elements in the reaction so that nothing is lost and nothing is gained. If you think back to this example we talked about in class where you guys looked at this data here, if you were to add up all of the reactants, in this case it's just one, this 0.325 number, if we added up the mass of the products, these two, if we add these together we're going to get 0.325. So the mass of the products and the reactants have to be the same. Okay? Now, when we talk about balancing different equations, basically we would have to figure out what number goes where in order to make these even. So, if we have hydrogen reacts with oxygen to form water, this example here. So, when you look at this says H2 plus blank O2 yields H2O. We have to figure out if we need to put a number in any of these places. The first thing that I would do is to look for oxygen. If we look at oxygen here and oxygen here, we have 2 oxygens over here, but we only have 1 oxygen here. If we were to put a 2 here in front of water, now we're going to have 2 oxygens. That balances, we have 2 on each side. But now we have 4 hydrogens over here and only 2 here. That means we're going to need to put a 2 here so that those balance out. So all in all, we're going to have a 2 here, so 2 H2O plus 1 oxygen yields 2 waters. You can double check your atom count on both sides. Now we're going to have 4 hydrogens here, 4 here, 2 oxygens here, 2 here. So those will check out. Okay. Now, assuming all reactants react, if we started with 5 grams of hydrogen and 4 grams of oxygen, how many grams of water would be produced? In order to answer a question like this, you have to keep in mind the law of conservation of mass. So, if we're going to have the same amount of reactants and products, we're going to want to add those numbers together. So we're going to have 9 grams of reactants, so we should have 9 grams of products, which is water in this case. Okay. Now, we're going to look at this next example here. Before we do that, I want to throw in a reminder. Remember the 9 polyatomics that I told you in Unit 1 you need to memorize? These are going to come back to play here. So if you do not have these memorized, I promise you will struggle during this unit. So if you haven't done it yet, I would make sure you memorize these, or try to memorize them again if you weren't successful before. You need to know these 9 and their charges and what they're called. So for example, if I tell you you have sodium sulfate, you need to know that that sulfate part is SO4 with a -2 charge, so you can write your formulas. Also, the 7 diatomics are going to come into play here. We need to know the 7, that as we write them out, if we just say oxygen by itself or chlorine or bromine, those come in pairs. So if we look at this example here, these are the same 3 examples that we started to do on the board here, but these are not balanced, so now we need to work on balancing them. So the first one, the lithium chloride reacting with sodium sulfate to form lithium sulfate and sodium chloride. First thing I would look at, I think it's easiest to leave oxygens and hydrogens for last because those can be the trickiest to balance. I'm just going to do a visual check here. So we have lithium, I have 1, I have 2. Already I'm finding a problem. So then I might say, okay, well I have 2 over here, so what if I put a 2 here? Some of this turns out to be trial and error. So if I put a 2 here, now I have 2 lithiums, so that checks out. But now I have 2 chlorines, I only have 1 over there. So I want to look at the other half of this compound. I have 1 sodium here, but I should have 2. So then what if I put a 2 here? Now I have 2 lithiums, 2 chlorines, 2 sodiums, and then I'm going to have 1 of this whole compound here, this sulfate. So that's going to check out. I'm going to look at this next example here. So I have Fe plus O2, and then Fe2O3. So the first thing I would do is to look across. So I see, okay, I have 1 iron, now I have 2 irons. So what if I make this a 2? Okay, now I have 2 irons, but now I've got 2 oxygens here and 3 here. There's no way I can make them into each other. So then I might need to put a 2 here, so this is even. So I can put a number here. That means I got to change this 2 in front of the iron. So now I have 4 irons. I have 6 oxygens here, so I need to put a 3 here, so that becomes 6 as well. Now this last example, again I would just do a first visual check. So Ag, silver, I only have 1 here, but I have 2 here, so I'm going to put a 2 here. Now I keep reading across, alright, I have 1 nitrate, 1 nitrate. I have 2 hydrogens here. I'm going to need to put a 2 here. Double check, I have 2 nitrates, there's a 2 here, okay, so now there's 2, that looks good. I have 2 hydrogens and 1 sulfur, so that looks good. So that's essentially the basics for bonding and balancing equations when we talk about reactions. So tonight the homework assignment is lesson 2 in the practice packet. And just a note, we will have a quiz on Monday. It will be a shorter quiz that will only take about half the period, and it will be after we review the homework problems that are assigned tonight, the lesson 2 in the practice packet. So if you know the problems, how to do the problems that I'm assigning tonight, and you know your polyatomic ions, you should be good to go for the quiz.